Hello candidates, last time we looked at different types of pulleys, and specifically we looked at the single fixed pulley. Now this time we are continuing and we are going to look at the single movable pulley. So by the end of it all, we should be able to compare and we get the differences and the similarities. So a single movable pulley is the type of pulley in which the block and the wheel move along the rope. This is the type of pulley in which the block and the wheel move along the rope. So the wheel is supported by two ropes, and then the rope is pulled upwards. So that means the direction of the effort goes up. Then each rope shares half of the effort that is needed. The rope moves twice as far as the load, and the mechanical advantage of this machine is 2. So the advantage of using this pulley system is that the pulley, less effort is needed to do work. And then its disadvantage is that work is done slowly. So when you try to compare this single movable pulley to the single fixed pulley, we've said in here, in this system, less effort is needed, and then the work is done slowly. When you take a look at the illustration here, this is exactly what we are trying to say, that the effort moves up. You can see that the wheel is supported by two ropes. So we can have the effort this side and the effort this side too. This is the fulcrum, this is the block. So the whole block and the wheel will move along the rope. So you can see that the direction of force does not change, because the effort and the load will take the same direction. They will all go up. So looking at this diagram, we have the load as 50 newtons. We can do some calculations, but then what we need to take note of, or what we should not forget, is that the mechanical advantage of this pulley is 2. The mechanical advantage is 2. So if this is the load force, 50 newtons, and we are required to find the effort, how can we find it? We shall simply say mechanical advantage is equal to load out of effort. So we already know that the mechanical advantage of a single movable pulley is 2. And then our load force we can substitute is 50 newtons. And then what we are looking for is the effort, which we don't have. So we can just multiply by effort both sides, this side and then this side, so that this effort and this one will cross out, and we have effort times 2 is the same as 2 effort, and this one will be equal to 50 newtons. So you can see that we have 2 efforts, but then we want 1. So we can divide by 2 this side and then this side, so that this 2 and this one will cross out to give 1. And then we shall remain with our effort, which is equal to 50 divided by 2. We shall divide by 2. This is 1 and this is 25. So we shall have effort is equal to 25 newtons. And that will be our final answer. So alternatively, we can use another method where we can say that the load force, we are looking for the effort force. The effort force is equal to half of the load force. So we must know where this comes from. If we've said the mechanical advantage is 2. And we've said that the effort needed to do work is half of the load. So this is where we get the formula from. The effort needed to overcome the load force is always half of the load force. So this machine simply reduces the effort needed to do work. So we shall say this is equal to half times our load force, which is 50 newtons, by 2 here we shall have 1, and by 2 we shall have 25. So effort will be equal to 25 newtons. So you can simply choose from the two methods, choose whatever is simpler, and you apply that to do any calculation on the single movable pulley. We can have another example here. In the first place, we've had the load being indicated on the diagram, but this time they have not drawn for us. They are saying if the effort of 10 newtons is used to lift a brick using a single movable pulley, calculate the load force. So in the first example, we've worked out the effort force. Now this time we are working out the load force. We shall simply say mechanical advantage is equal to load out of effort. The mechanical advantage, which we already know is 2, is equal to load, that is what we are looking for, out of our effort that is given is 10 newtons. So we shall simply multiply by 10 newtons this side and then by 10 newtons this side, so that this crosses out with that to give 1, and we shall have 20 newtons, because 10 times 2 is 20 newtons, is equal to load. So here we can just interchange and we say load is equal to 20 newtons. And that brings us to our final answer. But alternatively, because you should know that we have two methods, we can also apply this kind of method, and we say load, because that is what we are looking for. Load is equal to 2 times the effort. So our load will be equal to 2 times the effort given to us, which is 10 newtons. Therefore, load will be equal to 20 newtons. So finally, that is our answer. You can see that we shall get the same answer using the two methods, but this is just up to you to choose whatever is simpler for you, and then you apply it. Now, like we said at the beginning, we need to come to a conclusion. We are looking at comparing the single movable pulley and the single fixed pulley. So this is a list of the differences between a single movable pulley and then a single fixed pulley. So this side we have a single fixed pulley, and this side we have a single movable pulley. So this is just a summary form, but when you're asked, you say in a single fixed pulley, work is done faster, while in a single movable pulley, work is done slower. So work is done faster in a single fixed pulley, then work is done slower in a single movable pulley. Then you can still use this when you're looking at the advantage of one of them and then the disadvantage. The second difference is that the single fixed pulley changes the direction of force. Just like we looked at this in the diagram, that in a single fixed pulley, the effort goes down and then the load goes up. But when we came to a single movable pulley, we saw that both the effort and the load will take the same direction. Then the effort is equal to the load force in a single fixed pulley. Whereas in a single movable pulley, the effort is half the load. So the effort force is half the load force. Then The mechanical advantage of a single fixed pulley is 1, and that of a single movable pulley is 2. So that brings us to the end of this session. I hope you've learned these differences and the similarities. The work for this lesson will be attached to the video clip. Please watch it carefully and attempt those questions and submit them. Thank you.